Hello everyone. Today I will solve five hard-coded problems and tell their solution and what I thought. So here's the format. First I will solve a problem and the moment my solution gets accepted, I will explain my thought process, probably by using comments uh, on text editor. So I am going to solve problem from Kenko seed. It is a great seed. Medium problem. I will solve medium problem from question 30 to 34. I will also do CSCS and other, but let's see. Okay, I will tell you the logic now. First, let me code new CPP 30 left, left, left. I hope Ellen is defined. I don't even remember my template. No, Ellen is not defined. The recording stopped for some reason, but I didn't do anything, so it wasn't a problem. And I actually have to explain the logic afterward. Then return. Let's see. Will work. Okay. Wait. uh, Yes, so I'm missing one test case. What if both have one? Okay. Equals to 1, and then m equals to 1, we out 1. Return. I missed it third test case, which was pretty simple. I hope the recording is still going on. Yes, it is. Uh, okay. So here's the logic. So I lost the code. Okay, I got the code back. So what's the logic? Assume there be this, this. Okay, so assume there are like that number of looks like this. So see, this one we will first flip this. This one will be flipped first time. Then we and this, and this will be flipped once. Then we could flip this. This would be flipped twice, 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 once, once. Okay, and then we would go here. So it would be twice, 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 one, once, once. Okay. And suppose we now flip this. So it would be twice, four times, once, once. So this done. Now flip this twice, five times, four times, and twice. So if we like assume a center, then this will be flipped nine times as one times itself and one times the surrounding corners. So when we are, and this would be flipped in total four times, and so and this should be flipped one, two, three, four, five, six times. Okay, so this way the corner one would be flipped 6 times, and the corner one would be flipped 6 times, and the sides would be flipped 4 times. I calculated it wrong and calculated the sides to be 5. That's why I was getting it wrong. And the all the middle one would be 9, flipped 9 times. It's basic combinatorics. Not even basic combinatorics. It's just logic. So that it would at the end would look like this, and it would look like this. Okay, so it was the normal case. So we just have to calculate the answer for normal case would be n minus 2 times m minus 2, as we have to calculate the inner square, the area of inner square. But there are two special cases. Suppose there is where m or n is equal to 1. So I handle them as one case. When m is smaller than n, then we will switch m in this case. So we can just, without loss of generality, we can we can assume n is smaller than m, and n equals to 1. N is equal to 1. So in that case, it would look something like 0, 0, 0, 0. Let's assume the case with 7, because it was an example. So 1, 2, 3, 4, 5, 6, 7. So this would be flipped twice, one by itself and one by the one inside. This would be flipped once, I mean thrice, 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 twice. So when it is odd, then the bottom one is on top, and when it is even, then the top front part is on top. So we would get answered as n minus 2. Basically, as n is equals to 1, so we I didn't have to multiply it by 1. And if the answer is, and if both m and n equal to 1, then it would only be flipped once. Therefore, the answer would be 1. So this was a pretty simple problem, and for some reason I calculated it wrong, and that's why it took me some time. So it is solved now. Now next one, for adjacent. We have sequence A1, A2, A3 to A1, AN. Each AI is a positive integer. Smoke's objective is to permute the element in A so that the following condition is satisfied. For each, the product of A and AI and AI plus 1 is multiple of It is one of those kind. It's very old problem that yes, ABC 69. I was able to tell it because first it is easy. Oh, I don't. I'm using anything more than basic. This logic is very simple behind this. The compiler is not here. Here, ing and compiler are also decreased my time. It was compiler's fault, not mine. So yes, it was not mine. So see, the logic behind it is actually pretty simple. Yes. So the logic behind is really simple. There are number in this format: A1, A2, A3, A4, A5, dot, AM. Okay, so see the log. You have to first subtract the number. So the easiest thing here is to first notice that we need n by 2 numbers of 4, multiples of 4. Okay, like we are doing integer division, so 3 by 2 is 1. Okay, so why do we need n by 2? Because we have to arrange it in an alternating order, so we at least need half of what there is, so we can one pair like 4, 1 comma 4 and 4, like the pairs could have at least one multiple, one multiple of 4. This is the key logic. Are some special case. Assume like this. It doesn't have has any multiple of 4, but it satisfies the logic because it has multiples of 2. So for it, what I have done, the logic goes like this. So first I will arrange all the multiples of 2 beside each other. Okay. But there could be one multiple of 2 alone with 1 or 3 wouldn't work. So first arrange all the multiples of 2. Uh, then, okay, so first to explain this, I have to go like this. I guess this is a positive case. Yes, I can leave that here only. So first arrange all the multiples of 2. So then we can see that 2 times 2 is 4, so it is divisible by 4. So yes, 2 times 1 is not 4, so that is problematic. We need one more 4. Not 4. Okay, so therefore we need one 4 tracing the trails of 2. Then we can arrange the order in this order, alternating order. So for that logic, we have to subtract n minus n should be equals to n minus c2 minus c2 plus 1. Okay, so it should be equal to n minus c2 plus 1 or n minus equals to c2 minus 1. That is the same, exactly the same thing. I hope my audio is still working and I'm not speaking. Okay, so my audio is still working. So n minus c2 plus 1. It is because we are first going to place all the 2's in a trail, and we should that trail should be leading by a 4. Then we have to place all the others in alternating order. So if we have enough resources to do that, then he can do it, or else he cannot do it. We just have to say this. So I first see the new n should be equal to this. Twos are in trail, so that doesn't matter. Multiples of two are in trail, so it should be six. It could be six also instead of two, and 14 also. So it doesn't matter. 10 also, so it can be 18. So all the multiples of 2 which are not multiples of 4 should be first followed. Then the mul- then there should be one multiple of 4, and then there should be all the others in alternative. So this would be new value of n, and we can place all the other in alternative order if and only if this new n. So I can call it new n if new n is greater, is less than or equal to twice of seafood that we have. So this is the basic logic and the code, and this that's why it worked. It was also basic math, maybe basic implementation I would call.